Hi guys, this is Vineet and I'm welcome you to this video. Today's video topic is date and time data types in Microsoft SQL Server. This is the part 5 of this video series. If you haven't watched the earlier 4 parts, please go ahead and do so. And if you have already watched part 1 to 4 for this video series, that's good. You can continue with part 5. And guys, if you are new to this channel and if you haven't yet subscribed to the channel, please go ahead and do so. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future and upcoming videos. So let me give you 5 seconds. Please go ahead and do so. Then we will continue with our today's topic, which is date and time data types in SQL Server. So guys, I hope you must have subscribed by now. So let's move ahead. Let me take you to notes quickly. So today we have to discuss on the time data type, and basically if we talk about this data type, it defines the time of the day, and time is without time zone awareness. So if we talk about this data type, and this is not time zone aware type data type, and this time data type is based on a 24-hour clock. Let me discuss some properties and their values. So syntax is time, and we can define the fractional second scale within the brackets. And usage, there are 2 examples. Here I'm declaring a variable my time. Variable name starts with @. So I'm declaring a variable my time of time type, and I'm taking the fractional second scale of 7. And second usage is here, where I'm creating a table using the create table statement. Table name is table1. Using one of the columns in the table. The name of the column is column1, and the data type of this column is time with a precision of 7. Now let's talk about the fractional second scale, which is defined within the bracket. So here we have defined 7. So let's talk about that. So if we talk about this scale specifies the number of digits for a fractional part of the seconds. So this 7 defines basically the number of digits for the fractional part of the seconds, or milliseconds you can say. And this can be an integer from 0 to 7. And if we talk about the application Informatica, this can be an integer from 0 to 3. And the default fractional second scale is 7. If we don't define anything, the fractional second scale is 7, which is 100 nanoseconds. So I've removed it, and let's talk about the default string literal format. The string literal format for time data type is hours, minutes, and seconds. And then we define the nanoseconds, which can be 7 digits long. And this is for Informatica. All right, let's move ahead. I think we can remove this Informatica thing. Let's talk about the range. So range is from altogether all the zeros through 23, 59, 59, all the dates to 999999. And let's remove the Informatica information that is not required. So let's talk about some of the element ranges where HH represents the 2 digits, which ranges from 0 to 23 defines the hours. And this represents the hours. Represents the minutes, and it ranges from 0 to 59. SS represents the seconds. It ranges from 0 to 59. And the precision scale N can be from 0 to 7 digits, and it ranges from 0 to 7 times 9. And that represents the fractional seconds. And let's move the Informatica thing here. And let's talk about the corrector length, and the 8 positions are minimum. So we need to specify the hour, minute, and second part. Other parts are optional. And a maximum of 17 corrector lengths can be defined, which includes hour, minute, second, and the fractional seconds part. Let's remove the Informatica thing. Now let's talk about the precision scale, and basically user specifies the scale only. Let's remove that, and let's remove this row as well. That is not required. All right, so let's move on to next property, which is storage size. So the storage size for time data type is 5 bytes, which is a fixed storage type. And this is the default with a default of 100 nanoseconds fractional second precision item. And let's talk about the accuracy it is accurate up to 100 nanoseconds or 1 milliseconds in Informatica. So accuracy is 100 nanoseconds, and default value is if you don't specify anything while declaring a variable, the time data type variable automatically takes 0.00000 for its default value, and this value is used for the appended time part for implicit conversion from date to date time to or date time offset. And if we talk about the user-defined fractional second precision, yes, it does support that. And this one is not time zone aware, and it is not daylight saving aware as well. Now, let me take you through some of the demos here. So give me a minute. So first demo is on converting the time and data type to other date and time types. So let me take you through that. In this demo, basically what we will do, we will describe what occurs when a time data type is converted to other date and time data types. And basically when the conversion is to time n, the hour, minute and seconds are copied. When the destination precision is less than the source precision, the fractional setting is rounded up to fit the precision. We'll talk about that shortly via examples. And the for let's take an example. Let me write some code for you, basically which will show you the result of converting a time 4 value to a time 3 value. Let's try to show you some conversions here. Okay, the SQL Server is being opened, about to get launched, should be up anytime. Okay, I think it's launched in the background, so let's see. Okay, so let's connect to the default instance of SQL Server. Let's connect to any of the databases. For my examples, I'm using AdventureWorks 2020. Use any of the databases because these examples are not database related, but yeah, at least one database is required to against which we can trigger a query. So let's start with the declare statement, and let's take a time from variable, and let's declare it with the precision of 4. It's of time type with the precision of 4. And let's take some value, time value over here, which is 12 hour 34 minutes and 54 seconds, and 1237 for the precision parts or the nanoseconds part. And let's use the another declare statement. Right, let's use the another declare statement and use another variable. So this time I'm taking time 2, and basically we are trying to convert time 4 into time 3. So here I'm reducing the precision of this value particularly. So I think when we convert it to time 3, it should get rounded off. The precision should get rounded off to 1 to 4. Let's see anyways. So let's assign the value of this time from variable to this time 2 variable, and let's try to print both the values using the select statement. So let's print time 2, and we can take the heading as time 3, and let's take the second variable for printing in the select statement, time from, and let's take it as time 4. So I'm converting the time 4 to time 3. So let's see if any rounding off happens over here. Let me close the quotes. Let's execute this statement. So it is showing some conversion failed when converting the, so let's see why it has failed. So I think we should be good, but it's not taking that. Let me check my code quickly. So there is an issue with the code. So the fractional part is not separated by semicolon, but with a dot. I need to specify dot over here. Now let's execute the statement. It will execute fine. So let's see what happens when this string literal gets converted into time 3. So it has rounded off because it was 1 2 3 4. If we round it off to 3 digits, it gets rounds off. So it rounded off to 12 34 54 and 1 to 4. And whereas the original string is printed via the time from variable here, which outputs the actual string literal as is. While doing the conversion from time 4 to time 3, the fractional second part gets rounded off over here. Now, if we take the same conversion and if we try to convert it into a date type, the conversion will fail. And error message 206 is raised, which will show us message like operand type clash, date is incompatible time. incompatible with time. Now, when the conversion is to datetime, and the hour, minute, and second values are preserved or copied, and the date component is set to 1900 0101. So time data type cannot be converted into date, but yeah, it can be converted into datetime, where date is automatically taken as 1900 0101, and hour, minute, and second values are preserved. So when the fractional second precision of the time when value is greater than the 3 dates, the date time result will be truncated, because the date time, the default precision for the date time data type is 3 dates, especially the fractional part. It does not store any dates beyond 3 dates. So it will discard any dates after 3 fractional dates. And let me show you with an example of a code. So let's take a time variable over here. Let's call it time, and let's take it as time 4. Slightly change the value. So let's change it to 1504 and 1237 as a precision. Let's take a date time data type over here. So date time I'm taking, and let's take it as date time type. All right, and let's assign the value of time to the date time variable. All right, and try to print the time variable first, which will print the string as is. The first variable will print this particular string as is, and let's change it here as well. The column header, which basically comes here, and let's take date time. Try to print that, and let's take it both within the quotes as well. Now, if this value gets converted into date time, so date value will be taken as 1900 0101, and 121504 is preserved, and it will take dates up to 123. Rest of the dates will be discarded simply. So we will get up till this point if we try to print the date time value for the same string literal. Let's see what happens. I've just executed the statement. So first we have tried to print the time variable. So string literal got printed as is, and whenever we try to convert it into date time, the date is automatically taken by default as 1900 0101. The time, hour, minute, and second are preserved, and only 3 dates of fractional seconds are preserved, because date time data type supports only 3 fractional dates. All right, so let's move ahead. Now let's talk about the conversion into the small date time. The same data is converted into small date time. The date is set to 1900 0101, which is the default date, and the hour, minute values are rounded up. So hour and minute values are rounded up, and the seconds and fractional seconds are set to 0 if we do a conversion of time value to a small date time value. So the seconds and fractional settings are set to 0. Now let me show you with an example of a code. So let me modify this code a little bit. So first line, we can take it as is. Let's modify it slightly. Let's take it as 59. Let's take 4 times 9 and try to convert it into a small date time value. And yeah, take it as small date time type, and assign the value of time, which is the string literal. Now let's try to print this small date time over here. So what happens when we try to print it? So if we try to print the time variable, this string literal will print as is. And if we try to print the small date time variable, because small date time is taking the value of time, which is this particular string literal. So small date time will print as, it will print a date because it has a date component. So it will take date as 1900 0101. And it will preserve the hour part, which is 12, and the minute part, which is 15. 59 will be set to 0, and 999 will also be set to 0000. Let's try to execute this statement and see what the output is. So first output is of time variable, which has printed the string as is. The string is printed as is over here. And if we try to print the small date time, it has printed the default date 1900 0101, and our part is preserved 12 hours 60 minutes, and second part is set to 00. Fractional seconds are not displayed with small date time, so the small date time data type does not hold any fractional seconds, so those are simply discarded. Now let me show you a rounding off example here. So here 59 was the second part. So for example, if we set the minute part to 59, the rounding off occurs. So if we try to print this statement now, for time variable, it will print this string as is. For small datetime value, it will round off this minute part to 13 hours and 0 minutes. Let's try to execute this statement. So this is rounded off, right? So these seconds are rounded off. One is added to the second, so we get to the 13-hour part. Let's try to see the conversion to datetime offset 10 type. If we try to convert the time data type to datetime offset 10 data type, the date is set to by default to 1900 and the time is copied as is, and the time zone offset is set to plus 0000, which is the UTC time zone. And when the fractional seconds precision of the time and value is greater than the precision of datetime offset 10 value, the value is rounded up to fit. And let me show you with the help of an example quickly. So let's take the first line, let's modify it a little bit. Let's take 15 for a minute part and 4 for a second part, and let's take this as 1237. All right, and let's take the variable name as datetime offset. So here time has a precision of 4. Let's take datetime offset with a precision of 3 here, and assign the value of time there. And let's try to print this variable over here. And let's take the column header as the datetime offset. So when we try to print this statement, the time variable will print as is. This will print the string as is. And if we talk about the date time offset, the date will be set to 900 and the hour, minute, and second component is preserved. It will preserve the 12:15:04 part. And regarding the fractional second part, it will round it off to 1 to 4 because we have taken the 3 precision here for datetime offset. So it will round off this particular part. It will set it to 1 to 4. And for the offset part, it will take plus 0000 as the time zone. So let's see what is the output. So here we see for time variable, it has just printed the string as is. For the date time offset, it has taken the default date, which is 1900 and the hour component is preserved, the minute component is preserved, the seconds component is also preserved. The precision component is rounded off to 3 digits. It rounded off to from 1237 to 124, and the offset part is taken as 00, which is the UTC time zone. Now let's talk about some another conversion. So when we convert to datetime to when the date is set to 1900 that we are aware, the time component is copied and the time zone offset is set to 0000. And when the fractional second precision of the datetime 2 value is greater than that of the time and value, the value will be rounded up to fit. So here we are reversing some scenario. So we are talking about the datetime 2 data type here, not the datetime offset. I was talking about the datetime offset. I was talking about the datetime 2 data type. So when we convert the time data type to datetime 2 basically, right, with the n precision. So let's take a datetime 2 type with a 3 precision. So rounding off as well, right? We have taken a precision of 3, so this will round off to 1 to 4. And for date part, it will take 1900 as the date part. And the time component is copied as well, which is this part. And the zone offset is basically set to 0000. Basically, the datetime 2 data type does not hold the offset information, so I think that will be ignored. So here we don't have any offset information, and yeah, datetime 2 data type also doesn't display the offset information. And the fractional seconds will be rounded off as we are checking 3 as precision. So let's try to print this statement quickly. Let's take it here and let's take it there. All right, let's try to print it. So time value is printed as is, and for datetime 2 data type, the date is taken as default 1900 and the hour component is preserved, the minute component is preserved, the second component is also preserved. But the fractional second part is rounded off to 3 digits. It is rounded off to 124. So that is what happens when you convert the time data type to datetime to data type. Go to notes. So this demo is done where we talked about converting the time and data type to the date and time types. Now let's come to next demo where we are comparing the date and time data types. So we are not comparing date and time data types. Let's see. Let's first talk a little bit about converting the string. Okay, let's ignore that. Let's directly go to this demo. Let's go through this demo where we are doing a comparison of the date and time data types. And let's take some queries quickly. Although we have shown you that in the first demo as well. But yeah, let me show you some separate set of queries. So let me type in some code. All right, let me copy in some code statements. Give me a few minutes. All right, guys, I've copied in some statement. These statements are quite simple, where we are using the select statement with the cast function, and we are converting a string literal, which is basically the string literal, to different type of data types. First, we are taking the times 7 data type, right, which will display this string in a particular format. If we try to print it as time 7, right, it will only take the time part with the 7-day precision. So this will be taken. Let me remove these spaces. I think these are not required. These are additional. So similarly, we are converting the data type into various other data types. So if we convert the same string literal to a date, only the date portion gets preserved, which is this. And if we convert it into small data time, the date portion is preserved, and the hour and minute portion will be preserved, whereas the seconds and millisecond portion will be set to 00. Similarly, we are doing some other conversion into date time and the date time 2 and the date time offset data type. Let's see. Let's try to execute this statement and see the result. If this string literal converts to a time 7 data type, the time portion is preserved along with the fractional part, which is 7 dates. It is preserved, whereas the offset information is not preserved. When we convert the same string literal to a date type, only date is preserved. When we convert the same literal to a small date time data type, the date portion is preserved and the hour and minute portion is preserved. Rest is set to 00. The fractional seconds are not preserved. If we convert it to date time, um, up till this portion is preserved, and also the fractional part is also preserved. All right. Here we have not taken the offset information, so this will display as is for a date time. Now let's convert the bigger string with the offset information to a datetime 2 data type with a 7-day precision. So this will store this and not the offset information, like what is happening here. And if we print the same string literal with a datetime offset 7 data type, it will print the offset information as well. So that is what I wanted to show you. We are done with this demo as well. Now let's go to another demo. Let's talk about inserting valid time string literals into a time 7 column. So let me show you some examples. So I will use different type of string literals. Here I've used the same string literal, but let me try to use different type of string literals. So let me first copy the string literals from somewhere. Give me a few minutes. Let me create some. So guys, we have taken various string literals over here. Let's try to print them by converting them into the time 7 format. So let's take it as time 7, and let's take the time 7 as the header name. All right, so let's do the same thing here. Copy this on every line. Let's try to convert all of these strings into the time 7 format. So let's take the rest of the portion here. Now let's try to print these statements. Let's execute. So let's see the result of these statements. Instead of using different selects, I can use the single select as well. but I need to separate the statement out with the commas. So let's put comma after each and every statement so that all values should come inside the columns. So let's execute it. So it is showing some incorrect syntax near here. So last statement does not require the comma. Let's execute it. So if we convert this string to times 7, it is printed as the hour part, minute part, and second part is preserved, and 123 AM is converted into 123 and 4 times 0 because we are taking the time 7 value, so there will be a 7 day precision. And if we take this value, it will print up till this point, which is shown here. And if we take the third value, it will take the same string and ignore the AM PM part. So for PM, it will convert it into a 24-hour format. For AM, it is taking it as is, but yeah, for if we take PM, it converted into a 24-hour format like this. So it has converted 1 PM to the 13 hours. Now, if we convert the 1 AM and this string into times 7, it will ignore the, as it is PM, it will convert it into 130101, right? And it will preserve the fractional rate part. And if we just convert 1 AM, which is 010000, it will take as 01000000, and for fractional 78 it will take 7 times 0, which it has taken here. And similarly for this string, it will print as same. And for this string, 1 hour 1 minute 1 second, it will print the string as same. And if we talk about this string, it will print the string as same. And about the last string, it has the offset information plus 1 and 01, 1 hour 1 minute. So what it will do is it will print the hour, minute, and second part, and it will also print the fractional rate part, but it will ignore the offset information altogether because time 7 does not store the offset data. So guys, we are done with this demo as well, and let's try to move to next demo where we are talking about insertion of time string literal into columns of each date and time data type. So here also what I can do, I can take different type of strings against the different type of data type. I can show you that. So let me take you through this demo. Let me copy in some strings. So guys, here we have taken different type of string literals with a different data type. First one is time 7, date, small date time 2, and daytime offset. Now let's try to execute this statement and see how this string literal gets printed. So I've executed the statement, and if we talk about the first string literal, which is converted to times 7 data type, the same string literal will get printed like we can see here. And in the second scenario, we have taken the date string literal and converted it into date. So date will print as is. So that's why this has printed as is. And let's try to convert 12 12 12, which is our minute and second part, into a small date time. So it will preserve the hour minute part, and it will round off the set the second part to 0. So it has date component as well. So for date, it will take the date default as 1900 0101, like it has taken here, and it will preserve the hour and minute part and set the second part to 0. And if we convert this string, which is 12 12 12 fractional seconds 1 2 3 into date time type, it will, as it has the date component, it will take 1900 0101 as date, and it will preserve the hour, minute, and second part, as well as the default precision for date time is 3, so it will all preserve all the data like it has shown here. Now let's try to convert another string, which is this 12 12 12 1 2 3 4 5 6 7 into date time 2 type with the precision of 7. So here date component is also involved, so date will be taken as 1900 0101, and the hour, minute, second component along with the fractional second component will get preserved, like we can see here. All of the items are preserved. And if we convert the same string into the date time offset 7, everything is printed. The date is printed as 1900 0101. The same string is printed, the hour, minute, second, and the fractional second part, as well as along with that the zone information is printed as plus 0000, like we can see here. So I hope you liked all the examples and you liked all the videos. You can practice them as well. While you're watching this video, you can write out this code and practice that along with me. So if you didn't get the thorough understanding, please watch this video again and try to write down the code as I'm writing out. So you can pause the video and write down the code and then try to follow up with me during the video. So you can pause it at various places. Go through the video again, pause it whenever you like, go through the concept thoroughly and try to understand it in a better way. So guys, we are done with the date and time series basically, and this was the last part of this video series, date and time data types. In our next series we will start off with the, let's see what we can start off with. We can start with numeric data types. So we'll talk about the numeric data types. That will be another series. Let's see how many videos it will take to complete that numeric series. I think it should take around 6 to 7 videos will be required for covering the numeric data types. And I hope you like the today's video, and if you really like today's video, please go ahead and click the like button, and if you haven't yet subscribed to the channel, please go ahead and do so. There's a subscribe button below this video. Click on the subscribe button, it will give you a bell icon. Click on that bell icon, it will give you certain notification parameters. Select all notifications to get notifications to getting all my future and upcoming videos. And guys, also share this video with your friends in case you have a huge network of friends who are also working in SQL Server, and if you feel that this video will be useful for them as well, you can share my videos with them. And do subscribe to my channel, and also share in your comments, guys. You can send me an email as well on my email address, which is vrmavane@gmail.com. And guys, if you would like to donate something to our channel, please go ahead and do so. You can do it via two ways. Either you can go to this hyperlink which is given below, the HTTPS link for the top.net.io page. You can open up this complete page, the exact URL you need to type in the browser address bar, and once you open my top.net.io page, you can contribute your donations there. Apart from that, if you are using any UPI apps like Google Pay or Phone Pay, you can pay to me directly by that as well. So I've given my UPI code over on the right hand side. You can scan that code using any of your UPI apps like Google Pay or Phone Pay. You can scan and make whatever donations you like. So in order to support this channel, donations are required so that we can create more useful content for you. So thank you so much for your time today on this video. You have a wonderful day. Thank you.